for summer demand. And the result could look like this. Reservoirs virtually empty when water's needed the most.
What we're looking at is about 800 CFS from Lake Almanor.
Gary Freeman of Pacific Gas and Electric Company hails the output of the Caribou Hydroelectric Plant here on the North Fork of the Feather River. PG&E manages its reservoirs for power generation and flood control, a distinction that may allow them more flexibility in adapting to climate change than state and federal water managers. In the 1990s, Freeman discovered a link between long-term hydrologic trends and climate change. In the lower elevations of the northern Sierra, primarily in the Feather River watershed, 1/3 of the winter snowpack had disappeared.
As things change, as times change, we have less snowpack and we have increased winter runoff from rainfall. It causes more uncertainty in the models. They don't perform quite as expected or as we've programmed them to. We're going to probably operate some of these reservoirs as the snow line goes up the hill. We'll probably operate them a little bit different and may carry over more water for our winter minimums into the winter than we normally would.
Much of the state's snowpack, especially in the lower and mid-elevations, may soon be history. Projections warn of a 25% or greater loss of snowpack across the Sierra in the next 40 years. Here in the Feather River watershed, a key source of water for the state, the snowpack could dwindle an astonishing 90% by the end of this century. Large multi-purpose dams like Folsom near Sacramento are managed for 5 very different and often conflicting uses: water supply, ecosystem, recreation, hydroelectric power generation, and flood control. The first 4 uses want a full reservoir. The last, flood control, prefers an empty one. The two extremes of climate change, more flood risk in the winter and less supply in the summer, will make finding a balance much more challenging.
This is not business as usual. Typically, the way the Corps and other federal agencies and state agencies have planned for water resource projects is to look back at the past and build statistical distributions that help us understand what a potential future may be. Under climate signals, that process may no longer be valid. If we just do business as usual, there's a potential for increased flood damages out of it and reduced water supply. We need to recognize that changing conditions require the science and engineering necessary to make predictions about a future. And it's an imperfect science. We won't know the answer every day, but the goal is to build the most robust possible set of rule curves and operational scenarios so that we can accommodate the potential floods, but at the same time ensure adequate supplies not only for ag and municipal and industrial, but also environmental supplies.
Less snowpack isn't the only threat to water supply. A warming climate means more variability, more extreme weather events, more heat waves, and drought. Droughts are natural in California. In fact, the paleoclimatic record shows that droughts have been much more severe in centuries past. Climate change increases the global circulation cells that encourage downward air movement over traditionally dry regions, like the Southwest and most of Southern California. Studies suggest that by the end of the century, the state may endure severe droughts every 6 or 7 years, dropping reservoirs to what managers anxiously call dead pool, a level so low water cannot be released.
Yet if you go to the drier end of things, that means you're putting greater demand on that same fixed amount that you can work with that allow you to go from year to year. So the system doesn't allow any benefit for the increased excess, but may end up with more demands placed upon it with more intense or longer periods of drought.
Drought, a shrinking snowpack, and increased flood risk are 3 very grave threats of climate change. Sea level rise is another. In 1854, the United States Coast Survey installed a tide gauge here in San Francisco. It's the longest-running record anywhere in the Western Hemisphere. Over the last 100 years, the measurements clearly show a sea level rise totaling more than 7 inches. And depending on how much the oceans warm and how much continental ice melts, the oceans could rise another 7 inches to as much as several feet by the end of the century. Sea level rise will affect the entire coastline of California, threatening real estate, infrastructure, and natural habitat. Perhaps the most dramatic change will occur in the San Francisco Bay Delta. Projections reveal just 1 meter of rise will almost double the size of the bay. Sea level rise will also threaten coastal freshwater aquifers. The increased pressure from an expanding ocean will push salt water inland, contaminating groundwater supplies. Climate change researchers acknowledge that no major studies exist. No one really knows how great this threat might be. Engineers in Long Beach are adapting by blocking future intrusion with recycled water.
Well, you're looking at the Leo J. Vanderland's water treatment facility. What it does is it takes reclaimed water treated at the Long Beach Reclamation Facility operated by LA County Sanitation District and treats that water at the highest level possible so that then we can then use it in our injection wells to keep seawater from intruding into our groundwater basin.
The recycled water is pumped to a fleet of injection wells. Like an underground moat, injected water blocks the ocean from moving further inland. These unassuming shacks, posted over several miles, are the only visible sign of the battle against seawater intrusion. From a human perspective, sea level rise happens very slowly. A half a foot over a lifetime doesn't seem like much. But here in the Sacramento-San Joaquin Delta, the hub of the state's water supply, it's a game of inches.
First thing you got to understand about sea level rise in the delta is a function of sea level rise. That is, the formation of the delta at the confluence between the Sacramento and San Joaquin River was driven by sea level rise. Over the last 5,000 years, as sea level has been rising over that time, the sediments that came out of the Sacramento and San Joaquin River were deposited there, right, where the delta is today. Everything that goes on in the delta is linked to sea level. So if you have a change in sea level in the delta, everything else has to respond, but it can't.
Over the last 100 years, the delta has been frozen in place with a network of over 1,100 miles of earthen levees. It is fixed. It can't adjust. It can't adjust to changes in runoff associated with climate change, and it can't adjust to rises in sea level associated with climate change.
And we're going to add about a foot of fill at this point, which is right on the edge of the gravel road, right next to the river here. We're going to raise it about a foot, and it's going to slope, and we only need about 16 feet for a proper levee roadway. But because we are looking at sea level rise in the future, we want to make sure it's wide enough so that we can just put material on top to raise it when we need to. So we're going to start about here, and it's going to be about 21 feet wide when we get done. And it'll put us right about in here. So
Gil Cozio explains the ongoing work at Bolden Island. His company, MBK Engineering, manages and repairs 600 miles, roughly half of all the levees in the delta.
Well, these levees, are not in the best shape, as you've heard. We're doing two things here. We're trying to stabilize them, and then we're trying to raise them and widen them to the point that we can accommodate sea level rise to a certain extent. And so we aren't totally capturing all the sea level rise that might occur in the next 100 years, but we're kind of getting ourselves ready.